So, hi everyone, today I will share my thoughts on the Gale-Shapley algorithm. And first, just a quick summary of what is Gale-Shapley algorithm. It is designed to solve the stable matching problem, and in its most classic form, we have two sets of agents, each with rank preferences over the other set, and the algorithm proceeds iteratively. So one set proposes to their top choice, and the other set tentatively accept the best proposal they've received so far and reject the rest of the proposals. And the key guarantee here is that the final matching is stable. No two agents would prefer each other over their current matches. And for example, this algorithm is widely used in real-world applications, such as matching medical residents to hospitals, assigning students to schools, or even in some job matching platforms, but that would be much more complex. So anywhere there are two groups with preferences over each other, the Gale-Shapley algorithm provides a way to produce a stable matching that respects those preferences as much as possible. And one thing I found particularly interesting while studying the Gale-Shapley algorithm would be that the use of counterexamples to prove whether a statement is true or false. And this was the first algorithm I studied systematically in class aside from set cover algorithm. And I realized that the algorithms often rely on rigorous and mathematical reasoning, which I found is challenging but also interesting. And also notice that reverse reasoning, like thinking through counterexamples, is a common and powerful technique in algorithm proofs. And it can be challenging because it requires imagining the outcomes that contradict what you might expect. And over time, I found it helpful to adopt a kind of recipe. So first, just assume the opposite outcome and then trace backwards step by step to see why it would or wouldn't be possible. So counterexamples are particularly powerful because a single one is enough to disprove the claim, and whereas the positive examples are usually insufficient to prove it universally. So learning to reason this way gave me a new appreciation for the precision and structure behind algorithms. And I'm still kind of exploring how to strengthen this kind of reverse thinking. And now I want to connect the Gale-Shapley algorithm to a real-world application, which is the dating app. So in theory, Gale-Shapley only allows one-to-one stable matches. But in reality, dating apps operate dynamically. Users can match multiple people over time, and their preference changes. The new users join and someone leave. So the dating app company and the dating app themselves don't strictly enforce stability. And instead, recommendation algorithms try to suggest users who are likely to mutually be interested, and in order to increase the chances of successfully connections. And this made me reflect on why Go can't always be applied directly to real life. So in virtual world, we can hope for perfect stable matching, but in reality, the top priorities are different. For the companies, for the dating apps as well, they may care about user engagement, their business objectives, and also complex social dynamics. Also, for the users, since the users are simultaneously exposed to all potential matches, the next match they have might always be better than the prior one. So their preference rankings are fully known. And because of these kinds of challenges in dynamic environments, I'm guessing that one way apps might adapt Gale-Shapley is by first using the recommendation algorithm to score potential matches based on users' features, then presenting the highest scores pairs to increase successful matches. And besides that, I also wonder, do dating app companies implement any other modifications to the algorithm as well? But that's all for my reflection. Thank you so much for watching.